time. Okay, so you're wondering we're at 9.7. Like I said, we're doing 6, 7, 6, 8. Then we do 9, 7, and then we go to chapter 12. Okay? So we're kind of making our own unit here. And this was just kind of thrown into chapter 9. And chapter 9 was when we had wholes and asymptotes and rational expressions, adding and subtracting, solving, and all that stuff. And then this was the last section that we didn't feel fit very well in there. So on here, this fits better in this whole topic that we're talking about. Probability of multiple events. So we have 2 events or more. We're going to be talking about probability. Dependent events are when the outcome of one event affects the outcome of the second event. Okay? And the independent events are when the outcome of one event does not affect the outcome of the second event. Okay. So let's look at these 2 examples. Classify each pair of events as dependent or independent. I roll a number cube. Number cube is a dice. Okay? So roll a number cube and then toss a coin. What would those be? Would they be independent or dependent? Independent, because whatever I roll on the die has no effect of how the coin's going to be tossed. So that would be independent. Very good. Pick a flower from a garden, then pick another flower from the same garden. What would that be? I'm looking at, would those be, when I go and pick another flower, the chances of me picking that second flower is it affected by what I picked on the first one? It would be dependent, because if I'm just picking tulips or something, and if I have 15 tulips there blooming, and I go and pick a rose first, I still have 15 tulips, right? But if I pick a tulip the first time, then I have fewer tulips the second time. So that would affect whatever I picked on the first one, the chances of me picking a tulip on the second one, right? So that is dependent. It affected it. So the probability of if A and B are independent events, the probability of A and B, you multiply them together, the 2 probabilities. And basically I looked at this as like when I'm talking about picking flowers out of a garden, they're consecutive events. One follows the other generally. Okay? So if the probability of A is 2/3 and the probability of B is 1/4, then the probability of A and B is the probability of A times the probability of B. So all you do is 2/3 times 1/4, which is 1/6. Pretty basic, right? Straightforward. Okay, let's look at the next one. Your favorite radio station is running a promotional campaign. Every hour, 6 callers chosen at random get to select 2 songs. You call the station once after 7 a.m. and again after 3 p.m. What is the probability that you will be one of the 6 callers both times you call? Now here's the box. At 7 a.m. they call 70 people call in to choose the song. After 3 p.m., 250 people call in. So I have 2 probabilities, 2 cases that are happening, that I will be one of the 6 callers both times you call. The one at before 7 or after 7 and again after 3. Thank you, because then it's not on here, so please tell me. Okay. The probability of the second. So the probability that you will be one of the callers chosen to select 2 songs after 7 a.m. in the first instance would be what? What would be the probability? How many called at 7? 70. How many are they going to choose? 6. Does picking 2 songs have any relevance in this problem? No. It's just part of the story. Okay? They could have been, it's only 6 people that they're choosing out of the 70. And those 6 get to choose 2 songs. Okay? But the amount of songs that they get to select is irrelevant to finding the probability. Okay? So your probability of being one of the callers in the first instance would be what? 6 out of 70. Now the probability of the second event, how many callers do I called after 3? 250. How many are they going to select? 6. It would be 6 out of 250. Why did I multiply? Matt? They're consecutive. It's the first and the second. You want to have them both happening, right? One and then the other. Remember in and way back we talked about that meant overlap kind of? So they both are happening. So you have this and this. You're going to be both times. You want to be one of the 6 callers both times. And you're getting greedy. You want to be at 7 o'clock and you want to be also at 3 o'clock. Okay, are these independent or dependent events, the 7 o'clock and the 3 o'clock? Does this one affect this one? No. It didn't affect it at all. Okay, so now, how would I figure this out? I would probably start reducing. I know 3 goes into 6 twice. 3 goes into here 125 times. And I know, or 2 goes into 6 3 times. I'm sorry. 2 goes into 6 here 3 times. 2 goes into 70 35 times. And if you multiply that, you will get 9 over 4, 8, 7, 5. Okay? Mutually exclusive events. If A and B are mutually exclusive, then the probability of A and B is 0. And we've all heard of Venn diagrams, right, in your science class? And that would be here's A, here's B. Is there any overlap? No, so it's 0 when they're mutually exclusive. Okay, so this is a big topic that I'm going to show you about the Venn diagrams later. So turn your paper over. Okay, on this one, if A and B are mutually exclusive, so I'm doing the probability of A or B. Or is a big signal that you will be adding in probability. They are mutually exclusive. So you have this and you have this. So you're going to take the probability of A plus the probability of B, and you're done. You're going to add those 2 circles. Here's A, here's B. And the probability of both of them is the total. Now, if they are not mutually exclusive, what that means in your Venn diagram is that you have some overlap. Here's A, here's B, but this area in here is part of both of them. So when you have this that they are not mutually exclusive, you still have or, but, so you add them, but basically you added this overlap 2 times, right? So you have to subtract the overlap. You have to subtract one of those. Okay? An example. I was just thinking about right now, if I had something like this, and I think you guys have all seen this kind of a thing before, if I'd have 1, 2, 3, 4, 5, if I would say, what are all the numbers of A and B, circle A and B, you would say 1, 2, 3, 4, 5, right? Would you say that? But in A, the elements are 1, 2, 3. In B, the elements are 3, 4, 5. So if I would just list the elements in both of them, I would be listing 3 twice, right? So you have to subtract that 3 once. You would go, here's A, here's 1, 2, 3, here's B. You're adding that, 3, 4, 5. But you have to subtract where the overlap happens, so you have to subtract the 3. I mean, when I'm just looking at listing what's in there. Okay, so that's the same thing applies to probability. If you're looking at the union of sets and the intersection of sets, which we did first semester. Okay, so let's look at some examples. Number cube, remember that's a dice. Hi, Hamza. Okay, so there's 6 sides on a die. Is there anyone not familiar with the die? Because I have one that I could show you. Okay, so what we're doing here is the word or. So I'm finding the probability of rolling a 2 or the probability of rolling a 3. I'm going to get it anyway. So if you have 6 sides on the dice, what would be the probability of rolling a 2? How many sides have a 2? 1. You have 1 side out of 6 sides. How many sides have a 3? 1. 1 out of 6, and you have 2 6, which is 1/3. Are those mutually exclusive? Yes. So I did not subtract anything. You can't roll a 2 and a 3 at the same time. Okay, now let's look at this. We're talking about rolling an even number, or the probability of a multiple of 3. So, rolling an even number, what would be my even numbers on this dice? 2, 4, 6. So what is the probability of rolling a 6? Or an even number, I'm sorry. It'd be 3 out of 6, right? You have 3 choices out of 6. Okay, now multiple of 3. What is a multiple of 3 on this dice? It is a 3 and a 6. So I have 2 choices. Are these mutually exclusive? That was our first question. Are those mutually exclusive, or do they have some of the same elements? So are they mutually exclusive? No. So what do we have to do? We have to use this formula. So we are going to subtract. What is the overlap here? There is 1/6. How about that? Now, what if I would have actually used this formula up here? You will get, let me finish this up. You get 4/6, which is 2/3. You always leave probability as a reduced fraction. Our book a lot of times puts it in decimal form, or percent we went as a reduced fraction. Okay? Now, on here, if you would have used this formula up here, P of A plus P of B minus P of A and B for this one, because they are not mutually exclusive. We have 3/6 plus 2/6 minus, if I would multiply these two together, 3, 6 times 2, 6. What would I get here? 6/36, which is 1/6. Voila. How about that? You get the same thing. Here you could actually see that there's only 1 there. But this is applying the formula. Okay? Okay, on here. So let you guys do all of these, 1, 2, and 3, and see how you do. What's up, Ibrahim? Got a question?
I got one.
You got a question? What's up?
Do you have to do that formula?
No, you can do that. I'm just showing you how by listing and also how the formula applies too. I would probably do it this way without the formula. I would just think in my head the 6 repeats. I would probably list them because you only have 6 choices on this one. This ties into 12 too, right here. That in what you're writing connected. What you're writing can connect this with the chart and that. Mm-hmm. Or future. I'm just trying. Okay. Alex, what did you do for number 1?
I did 1 6 times 1 6.
And you would get?
36.
And why did you multiply?
They're not mutually exclusive.
Okay, if they aren't mutually exclusive, why didn't you add them?
They're gonna share.
Because it says and also. So that it means it has to be in both. Okay, so that's, we're looking for the overlap, and when we're looking for overlap, then that's and is the big key that you multiply. Okay? Okay. Borna, what would you do on this one?
1 6 plus 6 or 1.
Why 6 6?
Sorry, 1 6 plus 1 6 equals 2 6, which is 1 5.
And why did you add?
Because it says or.
Because it says or. Why didn't you subtract anything?
Because it would say minus p.
It won't tell you to do that. But they're mutually exclusive. Is that what you were going to say? Sorry. Okay, Sarah, so you can do the next one. What would you say here?
3 6 plus 1 6 minus 1 6.
Plus 1 6 minus 1 6. Why did you subtract?
Because they both share 6.
They both share it as 6. I like how you say that. Okay, so your final answer would be
3 6, which is 1
3 6, which is 1/2.
half.
Okay? Up here, oh yeah. Okay, now let's look at this. About 53% of the U.S. college students are under the age of 25 years old. About 21% of the college students are over 34 years old. What is the probability that a U.S. college student chosen at random is under 25 or over 34? So, I want to say probability of under 25 or over 34. Okay, so is this mutually exclusive?
Yeah.
Why, Max? You're right.
Yeah, it is.
Why?
Because you can't be people who are under 25.
Right, you can't be under 25 and over 34 at the same time, can you? That'd be a trick. I'd like to have that one. I'd like to be younger than what I am. Okay, so do I add or subtract, Matt? Add, because it was or. So what is the probability of less than 25, William? What does it say up here? 53, right? How would I write that as a fraction? Over 100. 53 over 100. And here, this is 21 over 100. and you get 74 over 100, which will equal 37 over 50. Now, I'm going to add, that's a pretty basic question. I'm going to ask you a little bit harder one. What is the probability of being under 25 and under, no, or under 34? Okay, so we have the probability of being under 25. And we have plus the probability of being under 34. Will, what is the probability of being under 25? What's the probability of being under 25? Less than 25, that you're younger than 25. What would be the probability? It says right here, 53%. Okay, so it's 53 over 100. Now, does it tell you what's under 34? Can we figure it out? How, Si? You add them? Add what? You add 53 and 21 and get what?
Oh, wait, no, you subtract. 100
You add them to subtract 100
Yeah.
minus
Good. Okay, and excellent. If you would have this, here's 21, it's 53% is this. Here's 34, and you have 21% here. So what would be the population between 21 and 34? And what did you say, Abraham?
What?
How did you figure that out?
You add them, then 100 minus that.
Okay, you add them, which would be 74, and then you subtract them from 100. And so this would be 26, because it has to add up. You're going to be one of those ages, right? Okay, so under 34 would be how much of the population, Layla? Under 34 years old. 79. So you have 79 over 100. Do we have any overlap of being under 21 and under 34? Where's the overlap? Look at this. Under 21 and under 34. Where does it overlap? It overlaps under 21, right? So you're going to have to subtract the 53 out of 100, and you will just get 79. Basically, it's these two added together. But how this is worded, it's harder to see. Okay, let's look at this one. Suppose you reach into a fruit bowl with 3 red apples, 2 green apples, 1 lime, 1 lemon, 2 oranges, and select a piece of fruit at random. What is the probability that the piece of fruit is an apple or green? Okay, so what is the probability that it is an apple? First of all, how many pieces of fruit do I have? 9. So how many of them are apples? 5 out of 9. How many of these are green? Well, we know a lime's green, and we know green apples are green. So how many would you have? 3 out of 9, right? Here you have a green apple and a green lime. So 2 plus 1. Now, is there anything that got overlapped here? What got overlapped? Okay, the 2 green apples. How many are apples and green? Well, the only thing that is this. So you have to subtract 2 out of 9. You get 6 out of 9, which is 2/3. Okay? So on here, apple or red, Pooja, how many apples do I have? 5. So it would be 5 out of 9. How many are reds in?
Um,
3 out of red, or out of 9. And so you have probability of red, and then you're subtracting the probability of being a red apple. How many of those do you have? 3 out of 9, so you're going to end up with 5 out of 9. Now, do you guys know what citrus means? Citrus is like a lime, a lemon, and an orange. A grapefruit would be another citrus. I don't really know the definition of citrus. It's more acidic, yeah. They make juices out of them, but now they make juice out of everything, don't they? Blueberries, apple. Well, they've always made it out of apples. Apples isn't citrus. So how many of these are green? We have the green apples and the lime. How many of them are citrus? 1, 2, and 4. And then how many are green and citrus? Well, out of the citrus, only one of them is green, the lime. So that would be 1 out of 9, so you get 6 out of 9, which is another 2/3. Okay, one other thing I need to show you, and I don't have room, and I meant to put it up there, but it's in your homework and it's not in the note taker. You're going to have a problem, and I want to just explain it to you, but write this down. You'll see it when you get to it in your homework. I don't want you to have a bunch of questions tomorrow about it. It's in your homework, and I'll say that the events are not mutually exclusive. So if they're not mutually exclusive, are you going to have overlap? Yes. So do you have to subtract the overlap if you're adding? Yes. Okay, because they belong to both sets. So what they do, they have a chart, and they have P of A, they have P of B, wherever you have room on your page. This is just where I had one. And then they have P of A and B, and then they have P of A or B. And they have this chart, and I'm just making up examples of like what's in the homework. They might have 2 7ths here, 4 7ths here, and they have 5 7ths here. And you have to fill in this blank. Well, if they are not mutually exclusive, up in this first row, what kind of equation would I do with the probabilities? Anyone know? If they aren't, Hayato? What would you do with these if they are not mutually exclusive? How could I make this into an equation up here at the top? And then what do I do here? And then this equals it. So if you have this, if I add this and I have to subtract it to equal here, very good. What would I have to put here, Hayato? 1/7. That would be your answer. Okay, there's a chart like this on your homework. If you have something like this, 3/9, 5/9, 2/9, and you have this here, okay, that's a pretty slam dunk, right? After you know what to do, right? And why am I doing this adding and subtracting? Because in the directions it'll say P of A and P of B are not mutually exclusive. So that means that they have overlap. So I would just get 6/9, which is 2/3. And then what if I would have something like this? And here I would have 5/11, and I have 2/11, and I have 8/11. Jonathan, what would I have to put in this box? 1/11? 5/11, because you have to add it, subtract it, and it has to equal this. So you'd have 5/11 plus 5/11 is 10/11 minus 2 is 8/11. Okay, so you should be able to do your homework okay. Okay, so basically a wrap up, dependent, independent, mutually exclusive. If it's and, you multiply on the independent events. If it's or and they're mutually exclusive, you just add them. If they're not mutually exclusive, you have to subtract the overlap. Okay, keep your answer as a reduced fraction. Okay, very good. Done. Bye, everyone.